Now here, if you see in this equation, the minus sign we have taken. Now the question comes, why the minus sign we have taken? As here, heat transfer per unit time, it is seen that rate of change of temperature decreases or it changes with the distance. As heat transfer per unit time changes with the temperature per unit distance. As distance changes, the heat radiated get changed. That is the meaning of this. Just they have mentioned in the book also. Negative sign indicate that heat flow in the direction of decreasing temperature. Temperature decreases in the direction where the heat is flowing. That's why this minus sign they have taken. And from this, again you can find the value of K, and we can give the second definition of coefficient of thermal conductivity as they have given in the book. I will read it once. Coefficient of thermal conductivity of material may also be defined as rate of flow of heat. Rate of flow of heat per unit time is dq by dt. Rate of flow of heat per unit time means this dq by dt. Okay. Per unit temperature gradient. Per unit temperature gradient means change in temperature per unit distance. Rate of it will define coefficient of thermal conductivity can be defined as rate of flow of heat per unit time to the rate of flow of heat per unit time to the per unit temperature gradient when heat flow is right angle to the faces of thin parallel slided slab of material. What does it mean? Just simply I will draw it here. What they have done, just from this equation they have find the value of K. So how do we get the value of K? In magnitude, K equal to what? dq by dt divided by dt by dx into area. So this minus sign we have skipped for sake of understanding. So here we can say coefficient of thermal conductivity can be explained as, again defined as, amount of heat radiated per unit time per unit temperature gradient for a given area is said to be coefficient of thermal conductivity. It is applicable to parallel things. Just if you remember, in case of cube we have taken opposite faces which are exactly parallel to each other. So due to that they have just mentioned here parallel slab. So this is nothing but what? Thermal conductivity and coefficient of thermal conductivity. Now here, before going into detail further, just one point you must remember. What is that point? So in the first paragraph, in after thermal conductivity heading, the first paragraph would be there. There they have mentioned, thus good conductor of heat have higher thermal conductivity. If the heat is conducted by the material, it is said to be good conductor of heat, and if for that material thermal conductivity is high, and for bad conductor of heat, definite thermal conductivity will be less. So how much heat is conducted by the material, that can be explained in terms of thermal conductivity, and that is we have seen. And thermal conductivity can be given in terms of this constant K, that is said to be coefficient of thermal conductivity. Now further, the next topic of our syllabus is what? They have mentioned thermal resistance. What is meant by thermal resistance? So let's write down the thermal resistance. Now if you remember, just resistance in electrical circuit means what? This resistance in electrical circuit means what? Opposition to flow of current is said to be resistance. If more opposition, resistance is more. Flow of current, okay? Here it is thermal resistance means what? Opposition to flow of heat. Opposition to flow of heat is said to be temperature resistance, means opposition to flow of heat, similar to that of in case of electric resistance, opposition to flow of current. In this case, thermal resistance means opposition to flow of temperature. We are not going in detail of this topic, just directly you have to remember one equation they have given on next page, page number 136, left hand side at the bottom. They have represented this thermal resistance by RT, and they told the value RT is equal to, thermal resistance is equal to distance between the two faces divided by coefficient of thermal conductivity into the area, and that is said to be coefficient, that is said to be the thermal resistance. And this RT is also equal to what? They have taken one value for this RT, and that also can be written as equal to T1 minus T2 divided by P conduction. P conduction. P conductions means what? We can write this further. You can write this value further as equal to T1 minus T2. This P conduction means Q divided by T. Q divided by T. The amount of heat travel per unit time. Same thing you can write RT equal to X by K into A equal to T1 minus T2 divided by P conduction is equal to T1 minus T2 divided by Q, and this time goes to numerator. So you have to remember these are the formulas, or we can say equation for thermal resistance. And what is thermal resistance? Opposition to flow of heat. That's it. It is said to be thermal resistance. Apart from this, just they have given some application of thermal conductivity. So let's start with the first application they have mentioned. To cooking utensils. Cooking utensils means what? Suppose we have taken a pan. In kitchen we are using sometimes the pan, or suppose we are using different instruments, just like one of the best example, pan is made up of what? Pan is made up of metal, okay, aluminum, it may be copper, that type of pan, it may be of iron, and that iron, all these are made up of pans, or utensils are made up of. Utensils means general instrument we are using at the kitchen. That instrument has handle. Suppose such type of thing we have, I will try to draw it here. Such type of pan is there, and it has such type of handle here. That is said to be utensil, kitchen utensil. Now here, this is made up of either aluminum or copper, or it is made up of iron. Definitely all these are nothing but a metal. So when we heat this pan at the bottom, when we put it on the gas burner, it is seen that it get heated. As this pan get heated, heat transfer from this hot end to this cold end. When if we hold it in our hand, there is a probability that we may suffer from a heat, or our hand may get burned after some time. For that, what they will do, they will make some handle here. They will make some this handle here, and that handle is made up of insulator. And this kitchen utensil, they have some handle here. The handle is made up of insulator, just like a wood, or it may be made up of wood, or it may be made up of ebonite. These are the insulator of it. So you can easily hold in our hand without feeling any burning. This is nothing but one of the application of thermal conductivity. Heat get transferred from this to this end, but still we didn't feel the heat because the handle is made up of bad conductor. That is the first example they have given. Application, not example. First application of thermal conductivity. Second application they have mentioned, thick walls are used. Thick walls are used for a cold storage. Construction of cold storage. Suppose I want to make a room where I am going to store some material whose temperature is very much less than the surrounding temperature. The wall of that container must be bigger, thick wall we must use, so that no heat from outer side goes inside, or no heat come from inner side to outer side. So that type of container, or that type of wall, thick walls are used, and in that wall they will use a brick. And what is the function of bricks? Bricks work as an insulator, just like this handle, so that heat cannot go inside the cold storage, or whatever the cold temperature inside the storage, that can't come outside that particular things. That is nothing but a second application of thermal conductivity. Third one they have mentioned, to prevent ice from melting. Might be all of you are seen most of the time. In case of suppose a lot of people are using ice cubes in summer season to drop it in the juice to make the juice cold and so on. Ice cream, so ice cream should not melt, so that they will put it in the that particular ice box, and that box is made up of thermocol. Generally thermocol will put ice. Why we use thermocol? Why we can't use another made up of wood? Why we can't use it made up of metal? The basic reason behind this is what? Thermocol is insulator of heat. Heat cannot goes inside the box because thermocol has a property as it is bad conductor of heat. So whatever the ice inside that thermocol box, it remains as it is without melting, okay, for a long time. Apart from this, if you go to certain shops of ice, it is seen that they are going to sell the ice, but for some time, suppose no one is there, no one customer would be there, what they will do, they will just put that ice, big pieces of ice, and just fold them in bags, gunny bags. In your book they have used the word specially gunny bags. What are the gunny bags means? Gunny bag means what? They just take a ice and wrap it in a sack, wrap it in a sack that is made up of cotton or it made up of plastic, so that the heat cannot go inside, it can't melt the ice. That is nothing but a third application of this thermal conductivity. Now the last paragraph of this, they have mentioned the basic summary of this. See, low thermal conductivity can also be a disadvantageous. Low thermal conductivity can be disadvantageous. How it will be? When hot water is poured, when hot water is poured in a glass, we have taken a glass, we know glass is insulator of heat, it can't conduct the heat, so glass is insulator of it. When you pour a hot water in the glass, what will occur? Inner side of the glass get expand due to that hot water, but outer side can't get expand, and that is the reason quickly within a second or within a second or few seconds the glass get broken suddenly. When you take a glass and just pour a hot water in it, within some time it get burst or it get crack. Why? Because thermal conductivity at inner area is different than the outer. That's why it get cracked. Instead of glass, if you use a metal pot and if you drop a hot water in metal pot, definitely it never crack because it is conductor of heat. But glass is not a conductor of heat. That they have mentioned at the last. After that, there are two examples, 7.18, 7.19 in your book, and these examples depends on what? Thermal conductivity. Just overlook over that solid examples. Then let's go to the convection. Convection already we have learned. Now directly we go to the application of convections. So the first application they have mentioned, heating and cooling of room. Heating and cooling of room is one of the application of convection. We have seen the phenomenon of convection where heat transfer with the actual migration of particle. Particle carry the temperature, it will travel. So that is with actual migration of particle heat transfer from one place to other place. So what are the application? The first, heating and cooling of room. So the first one, heating or cooling of room. Cooling of room. This is the first application of convection. Application of convection. So heating or cooling of room. So might be all of you know, in summer definitely some people are using AC. AC, they are using AC means what? The AC is a device which make a room cooler. So what is the function of it? So initially the some particle of air get captured, and that get their temperature get decreases and that get thrown in the room. When the cooler particle comes in the room, the hot particles again collected, again they get cooled after some time. This process is going on. Hot particle collected, make them cool. Hot collected, make them cool. This circulation is going on so that after some time whole room or whole area of the house get cooled down. And this will occur. Actual hot particles are collected means what? The particle of air whose temperature is more, they get captured, they get cooled down and they get emitted again. So what is occurred? Each particle is coming to the instrument, it get cooled down and thrown in the same atmosphere. So the temperature get decreased in case of cooling, temperature get decreased with the actual migration of air particle. That's why this is the first application of this convection. Second one, in the same they have is heating. See, in some countries, especially in European countries, in winter season temperature is so small that it is in -4 degree, -12 degree. There are some places on the earth's surface whose temperature varies very less, and for human being or any animal to live in that area is quite difficult. Still some human beings are living there. How? Because they are using room heater. So just like a cooling AC, there are some heaters. What is the function of heater? They will capture a cold particle, heat them and throw in the atmosphere. Capture the cold one, heat them, throw in the same room. In this fashion, whole atmosphere of the room get heated, and that is said to be room heaters. So that is the first application, heating and cooling of room with actual migration of particle will be done. So this is one of the application of convection. Second, they have just mentioned here, cooling of transformer. Now this cooling of transformer, what exactly transformer? I hope all of you are well known about. If you don't know, don't worry, we are going to learn this in detail in 12th standard. Definitely if you pass in 11, then we learn this transformer in 12th. Now this transformer is a device, might be in some area you have seen that there are bigger machines was kept, bigger, this much big or like greater than this, they have kept one instrument, maybe have a green color or black color, the two big poles are there, and every time it gives some distorted voice, in night especially, it will produce a voice. That type of thing is said to be transformer that was fitted by MECB. To every area there is one transformer, so that for electricity, as transformer would be there, it is seen that transformer has two coils inside its part, it has two coils. Sometime the temperature of this transformer coil may get increased, and due to that it's quite difficult to make it cool. Now, how can we make it cool? So they will put this coil in the transformer, they will take some tank, in that tank they will use a oil, in that oil they have put that coils. Now that coils was kept cooled by the coil of transformer was kept cooled by this oil, and that's why it is said to be cooling of transformer. So what is the function of oil? Oil get touched to the coil which is heated, carry the heat, transfer to the another side, again colder particle goes there. This is cyclic process, and finally whole transformer is cooled down. Now where the heat of this oil goes, heat of the oil or oil heated in the transformer, they will transfer the heat to surrounding, and that is nothing but a second application, because oil particles are moving, carry the heat to surrounding. That's why it is part of the convection, and that's why it is said to be the application of convection. Apart from this, in your book they have mentioned free and forced convection. Free and forced convection, it is quite difficult to understand directly, so it is better to skip this topic here. Let's go to the last topic of this chapter, that is nothing but a Newton's law of cooling. What exactly Newton's law of cooling is, that we have to learn. So let's start with here, Newton's law of cooling. So as its name is Newton's law of cooling, definitely this law must get modified or invented by the scientist Newton. So it is said to be Newton's law of cooling. Now what exactly Newton's law of cooling is? Suppose when we have taken, just we have learned in last period also, in the same video earlier, when hot cup of tea we have kept on the table, after some time its temperature decreases, or ice cream was kept on the table, its temperature of ice cream get increased. What is the reason? It will exchange the temperature to surrounding. So this type of thing was first studied by Newton, and he has invented one law. That law we have to learn here, and one experiment he has done for this. That experiment we have to consider. Calorimeter, just I have told you, calorimeter is an instrument which is used to measure the specific heat capacity of material or substance. That we have skipped that topic, but at that time I have told you calorimeter is used to measure the specific heat capacity. So what they will do, they will take calorimeter made up of copper or aluminum. In that they will pour a hot water. Hot water was poured in the calorimeter, and they put one thermometer, and whole calorimeter is kept in a box made up of wooden, or there would be some wool to avoid the losses due to conduction and convection. So what they have done, so they have taken such type of calorimeter would be there. This is a pot made up of copper or aluminum. In this pot they will pour a hot boiling water. So this water was kept in this. So it is a water, hot water we can say, not simple. Hot water was kept in the calorimeter. Then this whole thing was kept in a box. So this is nothing but that box made up of wood. In that box they have kept this, and apart from this, to this side they have kept some glass fibers or wool as an insulator. Apart from, they will make the upper surface also close. While closing the upper surface by wood, this is nothing but wool of glass we can say, or insulating wool we can say. Then this is a wooden frame, wooden box, they will, in which they will put this, and they have made one hole here, very small fine hole was kept at the upper lid, and for this they have kept one thermometer. They will insert a thermometer in the material. So this is a thermometer. Now here what will occur, as the water is boiled, so definitely temperature of this shown by thermometer may be approximately 100 degrees Celsius, because boiling point of water is 100, so it shows 100 degrees Celsius initially. Then after that, what he has done, Newton has done this experiment. What he has done then, he has measured the time to decrease the temperature of water by 1 degree Celsius. So this is the temperature. So suppose first reading they have started from 0. Suppose temperature is 100 degrees Celsius. Then after 1 minute it may comes to be 99. 2 minutes it becomes to be 98. In this fashion, he has noted down the readings. First 100 degree it is 0 time, 99 degree 1 minute, 2 minutes 98. In this fashion, he's counted down this table was prepared by him, and he has taken a reading up to 100. The initial temperature is 100 up to 75 to 70 degrees Celsius, 25 degrees Celsius less. He has noted down the reading, and he observed that initially 100 to 80 or 70 degree, for 1 minute time the temperature decreases faster because it is hot initially. But later on he has observed that as temperature decreases after 60 to 50 degrees Celsius, after especially 50 degrees Celsius, it is seen that as time required to decrease the temperature of same water by 1 degree Celsius is much more than the initial reading. And this is the phenomenon he has done. Finally, after doing this experiment, he tried to draw the two graphs as they have given in the book. What are the graphs? The first graph gives the graph between temperature in degrees Celsius and the time, and that graph is like this, such type of graph that will come. And the second graph they try to find out between here dt by dt, where the change in temperature with respect to time. Remember, capital T means temperature, small t means time. dt by dt versus T minus T0, change of surrounding over temperature. T0 is a room temperature, this is a room temperature, this is boiling point of water means 100 degrees Celsius, higher than the room temperature. And they have plotted, and is seen that this straight line graph. And from this observation and experiment and graph, he has invented one law, that is nothing but what? Generalized law, Newton's law of cooling. What is this Newton's law of cooling? See page number 139, right hand side at top they have mentioned. According to Newton's law of cooling, that is a statement actually, rate of loss of heat means dt by dt, the rate of loss of heat of a body is directly proportional to difference of a temperature of a body and surrounding, provided difference of temperature is small. So if we represent dt by dt, change in temperature with time, is rate of loss of heat or temperature of body, is found to be directly proportional to higher temperature minus hot temperature of the body minus room temperature of the body. And this is said to be Newton's law of cooling. Now further, you can remove the proportionality sign, you can write dt by dt, rate of fall of temperature of body is equal to some constant c into T minus T0. Now this law is applicable provided this difference in the temperature of body with surrounding should be small. Then and only then this law is obeyed. That is said to be Newton's law of cooling. After that, there is one example, solved example 7.22, that is very important equation, very important example, because that is an example on this Newton's law of cooling. Such type of examples was asked in NEET and JEE. So just in this fashion we have prepared, just completed this chapter. Now next period might be we start the next chapter, sound. So just prepare yourself well, just watch my video. After watching it once or twice, try to understand the same topic whatever I taught you from your book, try to read it. Definitely it will increase your understanding. Now in the next period we will start the next chapter, might be we start the sound wave. So take care and let's see you in next video. Thank you.